Hey everyone, today I'm going to be going over the legal problem, fruit into baskets. So first, let's do the question. You're visiting a farm that has a single row of fruit trees arranged from left to right. The trees are represented by an integer array fruits, where fruits I is the type of fruit the ith tree produces. You want to collect as much fruit as possible. However, the owner has some strict rules that you must follow. You only have 2 baskets, and each basket can hold only a single type of fruit. However, there's no limit on the amount of fruit each basket can hold. Starting from any tree of your choice, you must pick exactly one fruit from every tree, including the star tree, while moving to the right. The picked fruits must fit in one of your baskets. Once you reach a tree with a fruit that cannot fit in your baskets, you must stop. Given the integer array of fruits, return the maximum number of fruits you can pick. So let's look at a couple examples. Starting with example 1, we see that a fruits array consists of 3 elements, 1, 2, 1. And so the output is 3 because we can pick from all 3 trees. This is because when we hit tree 1, we put the type in a basket 1. When we hit tree 2, we put the type in the tree basket 2. When we hit tree 3, it's type 1, which we already have in our basket 1. So we can put that in basket 1 again. If you look at example 2, the fruits array is an array consisting of 4 elements. 0, 1, 2, 2. And the output again is 3. And this is because we can pick from trees from the second to fourth tree. However, if we start from the first tree, we will only be able to pick from the first 2 trees. So this problem is a silent window problem. So how I'm going to solve it is with 2 pointers. I'm going to use 2 pointers, a left and right pointer, and also a bucket, which is just a dictionary, to store the type of fruits we have and the frequency. And this is the idea. We loop through the fruits array, and if the length of the bucket or the size of the bucket is less than or equal to 2, we only move the right array, so the right pointer. And each time, we add the type to our bucket. However, once the length of the bucket is greater than 2, we also start moving the left pointer as well. And the idea behind it is this. Assume from tree 1 to tree n, there's only 2 types of fruits, like fruit 1 and fruit type 1 and fruit type 2. So that means that when the right pointer is at tree n, the left pointer is still at tree 1. And what this does is we're going to preserve the length between these n trees. And so let's see a tree n plus 1, right? Let's see that's type 3, like that's another type. Well, what we're going to do is we're going to move the left and right pointer by 1 together each time. And so what that does, like I mentioned before, is that preserves this length. We don't know if this length is our final solution. We'll take our solution. But what we do know is that in the future, right, any sequence of trees that has 2 types, whose length less than this length, will be ignored. However, in the future, if there's like a sequence of trees with only 2 types that has length greater than this, then we'll increase the pointer's length later. So like I mentioned before, once the size or length of the bucket is greater than 2, we start moving the left pointer as well. And each time, we will move an occurrence of the type from bucket. And if a type has no more occurrence, we will move it completely from the bucket. So let's look at an example. So this is our fruit array, 1, 2, 1, 3, 3, 4, 4. On iteration 1, the left and right pointers are both at 0, and the bucket has 1 element. Well, the bucket has 1 entry. Fruit type 1 has 1 occurrence. So the key of the bucket will be the type and the value will be the occurrence. Going to iteration 2, we move the right pointer forward by 1. The left pointer stays the same. So left is at 0, right is at 1. Now our bucket looks like this. 1 occurrence of type 1 and 1 occurrence of type 2. Going to iteration 3, only a right pointer moves by 1. So left is 0, 0, right is at 2. Our bucket looks like this. 2 occurrences of type 1 and 1 occurrence of type 2. Going to the fourth iteration, our left pointer is a 0, our right pointer is a 3. This is what our bucket looks like. 2 occurrences of type 1, 1 occurrence of type 2, and 1 occurrence of type 3. Because now bucket has more than 2 entries, we're going to move the left pointer by 1 as well. So now left is at index 1, while right is still at index 3. And by each time we move the left pointer, we will move an occurrence of the type that the left pointer was at previously. So when left was at index 0, it was at type 1, right? So now we have to remove one occurrence of type 1 from the bucket. So the bucket looks like this. One occurrence of type 1, one occurrence of type 2, and one occurrence of type 3. Going to iteration 5. Our left is at index 1, right is at index 4. Our bucket looks like this. One occurrence of type 1, one occurrence of type 2, and 2 occurrences of type 3. Because the size of bucket is greater than 2, or the length of bucket is greater than 2, we have to move the left pointer by 1 again. And now, so the left pointer is at index 2. And because previously it was on a tree of type 2, we will move an occurrence of type 2 from the bucket. However, this means that we no longer have any occurrences of fruits of type 2. So we will move the entry. So now our bucket looks like this. One occurrence of type 1 and 2 occurrences of type 3. Going to the 6th iteration, our left pointer is at index 2, our right pointer is at index 5. This is what our bucket looks like. One occurrence of type 1, 2 occurrences of type 3, and 1 occurrence of type 4. Again, we have to move the left pointer because the size of the bucket is greater than 2. So L with the left pointer is at index 3 now. And when we update the left pointer, we also remove the occurrence of the fruit type the left pointer was previously at. So now we remove one occurrence from type 1, which means there's no more occurrences of type 1 left in our bucket. So we remove the entry completely. So now our bucket looks like this. 2 occurrences of type 3 and 1 occurrence of type 4. Finally, on iteration 7, our left pointer is at 3, our right pointer is at 6. And our bucket looks like this. 2 occurrences of type 3 and 2 occurrences of type 4. And remember that we're going to be using a while loop. So our right pointer will be updated at the end of the loop. So now our left pointer is at 3, our right pointer is at 7, and we completed traversing through the fruit array. So now the max length will be 4, or 7 minus 3. So now given that, let me start coding this. Like I mentioned before, we're going to have a left pointer, a right pointer, and a bucket. And a bucket to store the type and occurrence of each fruit that we occur. So left and right, the 2 pointers, they both start at index 0. So now we keep traversing through the array. And for like each fruit type we encounter, for each fruit we encounter, we get the fruit type, and we add that to the bucket. And if the length of the bucket is greater than 2, we start moving the left pointer. So, oops. So first, we're gonna get a fruit type that the left pointer is currently at, and we're gonna decrement an occurrence of that type in our bucket. I'm just gonna copy this. So now, if a bucket has no more occurrences of the fruit type, we just remove the entry completely from the bucket, and we increment left by 1. We increment right by 1, and we return their difference. So let me just do a quick double check to make sure I don't have any typos. Okay, should look good. I'm gonna do a quick test run. Okay, looks good. And let me submit. you can see that the efficiency of this the time and space efficiency of this solution is really good. Thank you all for watching.